So today we will look the remaining part of the particle on a sphere. In the last class we were looking at the two equations, that is the equations obtained by the method of separation of variables. One of the equation was the F equation. You may be remembering the F equation, that is d square F divided by d phi square plus m square F is equal to 0. This was the F equation. And there was another equation, that is the P equation or theta equation, and this equation was d square P divided by d theta square plus cos theta divided by sin theta, dp by d theta plus beta p is equal to m square p divided by sin square theta, where beta was defined as 8 pi square m r square by h square into e. This was beta. And the F equation is a familiar equation to you because you have already learned this type of an equation when you were going through the particle in a ring. There also you found the same equation, d square f by d phi square plus m square f is equal to 0. Therefore, you already know the solution of this F equation. The solutions are f is equal to 1 by root pi sine m phi, and f dash is equal to 1 divided by root pi cos m phi, and f double dash is equal to 1 divided by root 2 pi exponential plus or minus I m phi. These are the solutions of the F equation. And what we are going to look in detail is the P equation, that is the equation in terms of theta. And this P equation's solution is a bit tedious, lengthy, and we are not going to the full details of the solution or the procedure or the entire steps of the solution of this P equation. That is a bit longer and it is out of the scope of our syllabus, and what we can conveniently do is to jump into the solution. That's a good idea, right? So we are going to jump into the solution of these equations. Before that, we have to see that the right hand side there is m square, and we already learned that m can have the values 0, plus or minus 1, plus or minus 2, plus or minus 3, etc. Therefore, for each value of m there will be different sets of different P equations, and this P equation is called a Legendre differential equation. Legendre differential equation. For each value of m, we will get a different Legendre differential equations. But you have to note that except for 0 and for the plus or minus values, you will get the same plus or minus value of any number, you will get the same Legendre differential equation, because the square of plus 1 or minus 1 is going to be 1, or square of plus 2 or minus 2 is going to be 4. So no matter whether it is plus or minus, no matter what is the sign of m, that depends on the absolute value of m, right? So depending upon different absolute values of m, you will get a different Legendre differential equations with different values in the right hand side of the equation. So if m is equal to 0, I have put the symbol here. Then this symbol represents the absolute value, and for m is equal to 0, for in the case of 0 that doesn't matter, but when we are going to the other values of m, that is plus or minus 1, plus or minus 2, this is very important. So for m is equal to 0, we get a Legendre differential equation, that is d square p divided by d theta square plus cos theta divided by sin theta, cos theta by sin theta, dp by d theta plus beta into p is equal to 0. Right hand side is equal to 0. So the solution of this equation is a polynomial called Legendre polynomial. Legendre polynomial. Legendre polynomial. And the Legendre polynomial is defined as PLX is equal to 1 divided by 2 raised to L factorial, d raised to L divided by dx raised to L. This is d raised to L, not dl. d raised to L by dx raised to L of s square minus 1, that is s square minus 1, the whole raised to L. And here you can note that we have introduced two terms, that is one is L and another one is x. X is nothing but cos theta, but L is a quantum number. It can have the value 0, 1, 2, 3, etc. Okay, and L is related to beta in this Legendre differential equation, and the relation is beta is equal to L into L plus 1. So for different values of L or different allowed values of L, we will have different allowed values of beta. So it means that beta can have only certain restricted set of values, and for all other values of beta we will not get a well-behaved wave function. Okay, so only for the values of beta defined by L we will get a wave function which is well-behaving or well-behaved wave function. That is a quantum mechanical requirement. So we can see which are the values possible for beta for different values of L, and let me take L in this column and beta here in this column. And if L is equal to 0, beta will be equal to 0, and if L is equal to 1, then beta is equal to 1 into 1 plus 1, that is 1 into 2, that is equal to 2, and if L is equal to 2, then 2 into 3, that is equal to 6. If L is equal to 3, then 3 into 4, that is equal to 12, etc. So these are the possible values of beta: 0, 2, 6, 12, etc. And we can have only the well-behaved wave function only for these values of beta. Okay, and if this is the equation, here is the solution. This is a polynomial, and this polynomial is called Legendre polynomial. We already mentioned that. What we are going to do now is we are going to find out certain values of Legendre polynomial, certain possible values of Legendre polynomial for the allowed values of L. So for L is equal to 0, the allowed value of the value of PLX or Legendre polynomial is P0x. So P0x is defined as 1 divided by 2 raised to 0 into 0 factorial, and d raised to 0 by dx raised to 0 of x square minus 1, the all raised to 0. So this is 1 by 2 raised to 0, 0 factorial, that is equal to 1, into d raised to 0 by dx raised to 0 of x square minus 1 raised to 0. X square minus 1 raised to 0 is equal to 1. Therefore, this is also equal to 1. Therefore, we have 1. So, P0x is equal to 1, or P0 cos theta. X is nothing but cos theta. P0 cos theta is equal to 1. We can calculate the value of P1x or P1 cos theta, and the value of P1x is equal to 1 divided by 2 raised to 1 factorial d by dx of x square minus 1, the all raised to 1. So that is equal to 1 divided by 2 into 1 into d by dx of x square minus 1, that is equal to 2x minus 0. So that is equal to 1 by 2 into 2x, that is equal to x. So p1x is nothing but x, or p1 cos theta is equal to cos theta. X is equal to cos theta. So what is p2x? P2x is equal to 1 divided by 2 raised to 2 factorial d square divided by dx square of x square minus 1 the whole square. Okay, that is equal to 1 divided by 4 into 2, 1 divided by 4 into 2 into d by dx of the first derivative of this. Okay, we will go for the expansion of this first. So d square by dx square of x square minus 1 the whole square, that is x raised to 4 minus 1 plus minus 2x square, that is s square minus 1 the whole square. So we have here p2x is equal to, let me write the balance here. Okay, I have to save the space because I am writing all this in an A4 paper, and it is better for me to save the space. So that is equal to 1 divided by 4 into 2 into d by dx of what is inside the bracket. This is not this one. Okay, what is inside the bracket, that is 4, the first derivative of what is inside the bracket, that is 4x cube minus 4x. Okay, and that is equal to 1 divided by 4 into 2, and there is a 4 in the as a common factor here. So let me put 4 here, and 4 into d by dx of x cube minus x, that is 3x square minus 1, that is equal to 4 and 4 are cancelled, that is equal to 1 divided by 2 into 3x square minus 1. And in other words, that is equal to 1 divided by 2 into 3 cos square theta minus 1, that is p2x, 1 divided by 2 into 3 cos square theta minus 1. And now let us go for p3x. P3x is equal to 1 divided by 2 raised to 3 factorial d raised to 3 divided by dx raised to 3. I hope you can see it is inside the field of the camera. Yeah, so d cube by dx cube of x square minus 1 the whole raised to 3. So that is equal to that is 1 divided by 2 cube, that is 8 into 3 factorial, that is 1 into 2 into 3, that is equal to 6 into d cube by dx cube, d cube divided by dx cube of x square minus 1 the whole cube. We have to expand it, s square minus 1 the whole cube. We can expand it by taking a minus b the whole cube. You already know that a minus 1 b the whole cube. I will write it here for just for a reference. A minus b the whole cube is equal to a cube minus b cube minus 3a square b plus 3ab square, that is a minus b the whole cube, a minus b the whole cube. Okay, a and b are small letters. Okay, so we can expand this one also, s square minus 1 the whole cube, in this way. So a cube in our case is x raised to 6 minus b cube is equal to 1 minus 3 a square b in our case is x raised to 4 into 1 plus 3 ab square, that is 3x square and to 1, so that is 3x square. So that is equal to 1 divided by 8 into 6 into d square by dx square of first derivative what is inside the bracket, that is equal to 6x raised to 5, this one will become 0, minus 3 into 4, that is 12 x cube plus 6x, that is the first derivative of what is inside the bracket, and that is equal to 1 divided by 8 into 6 into d by dx of first derivative of what is inside the bracket, that is equal to 30 x raised to 4 minus 36 x square plus 6, that is equal to 1 divided by 8 into 6 of first derivative of what is inside the bracket, that is equal to 120 x cube minus 36 into 2, that is equal to 72 ex plus 0. So that is equal to 120 and 72 has a common factor, that is 24. So we can take 24 divided by 8 into 6 into 120 will be 5x cube minus 3x. Okay, so that is equal to we can cancel the 8 and 24, then it will be 3 here, so 3 by 6, that is equal to 1 by 2 into 5x cube minus 3x, or in other words P3 cos theta is equal to 1 by 2 into 1 by 2 into 5 cos cube theta minus 3 cos theta. Okay, that is P3x. Now we have the values of different Legendre polynomials. So now let's move on. What if the value of m is not equal to 0? If the value of m is not equal to 0, we will have our Legendre differential equation like this one, what we drew in the previous paper. That is the p equation, that is the Legendre differential equation. D square p by d theta square plus cos theta by sin theta dp by d theta plus beta p is equal to m square p by sin square theta, where m square has a non-zero value. Okay, and if this is the value of if there is a non-zero value for m square, in that case we have a polynomial as a solution, and that solution is called associated Legendre polynomial. Associated Legendre polynomial. And the associated Legendre polynomial is defined as PLMX is equal to 1 minus x square raised to m divided by 2 d raised to m, I hope you can see, yeah, d raised to m by dx raised to m. Actually we are taking the absolute value of m, d raised to m by dx raised to m, PLX. That is PLMX, and this is called the associated Legendre polynomial. Here there are L and the absolute value of m. You have to note that it is the absolute value of m which is taken here, because only the absolute value of m matters. Because in the right hand side of the Legendre differential equation, you can see here that the right hand side of the Legendre differential equation, that is m square p by sin square theta, the sign of m doesn't matter, because if it is positive or negative, that doesn't matter. It is m squared, it is a square of m. So independent of the positive and negative value of m, let's see, these are the possible values of m, independent of the positive and negative values of m, we have the m square. So we are concerned only about the absolute value of m. That is why it is written here like this one. This symbol represents that it is the absolute value. Okay, so PLMX is equal to 1 minus x square raised to m by 2 d raised to m by dx raised to m, PLX, where PLX is already defined as the Legendre polynomial. We have already computed the values of PLX for different values of L. And now we can calculate the different associated Legendre polynomials for different values of L and M. For let's calculate for L is equal to 0, or we can see m for m is equal to 0, absolute value of m is equal to 0, and L is equal to 0. We can calculate for this set of values of m and L what is the associated Legendre polynomial. So in this case, PLMX is equal to P, L is equal to 0. So P0, 0x is equal to 1 minus x square raised to m by 2. M by 2 is 0 because m is equal to 0. D raised to m by dx raised to m, that is this d raised to 0 by dx raised to 0 of PLX. Okay, PLX, and PLX in this case is P0x, and we have already defined P0x, and the P0x, you might be remembering P0, you can also turn over your paper where you have written this. PLX or P0x is equal to 1, so let's put 1 here. So this is 1 into 1, that is equal to 1. So P00x is equal to 1. Okay, and for m is equal to 0, m is equal to 0, and L is equal to 1. So let's highlight this. We calculated now m is equal to 0 and L is equal to 0. Now we are going to calculate for m is equal to 0 and L is equal to 1. And in this case also it is like P LMX is 1, L is equal to 1 and m is equal to 0. So P10x is equal to 1 minus x square raised to m by 2. M by 2 in our case is equal to 0. D raised to 0 divided by dx raised to 0 of PLX. PLX in our case is P1x because L is equal to 1, and P1x we already computed P1x, and P1x is equal to x. P1x is equal to x. So in our case we have this is 1 minus x square raised to 0, that is equal to 1, and d raised to 0 of dx raised to 0 of x. That's the same function, that is x. So this is equal to x. So for all cases where m is equal to 0, we will get PLMX is nothing but PLX. So if we are calculating m is equal to 0 and L is equal to 2, then P20x will be equal to P2x, and P2x is nothing but half into 3 cos square theta minus 1, or 3x square minus 1, or half 3 cos square theta minus 1. And in the case of P30x is equal to here also m is equal to 0, therefore it will be equal to P3x, and P3x is equal to half into 5x cube minus 3x, or 5 cos cube theta minus 3 cos theta. Okay, so wherever we have m is equal to 0, we will get that PLMX will be equal to PLX. Okay, PLMX is equal to PLX. So that is obvious. When m is equal to 0, the right hand side of the Legendre differential equation will be equal to 0, and the solution will be Legendre polynomial that we already learnt. So Now we can go for the other values of m, that is very significant, and we can go for the value of m is equal to 1, m is equal to 1, and L is equal to 0. M is equal to 1 and L is equal to 0. Okay, we can check what is the value of this one. And in this case, when m is equal to 1 and L is equal to 0, then we have the associated Legendre polynomial, that is P L is equal to 0 and m is equal to 1 here. P01x is equal to 1 minus x square, 1 minus x square raised to m by 2. M by 2 is equal to 1 by 2 into d raised to m by dx raised to m, that is d by dx. Here in our case m is equal to 1, therefore d by dx of plx. Plx is equal to p0x in this case, because L is equal to 0 and p0x is nothing but 1. So d by dx of a constant, that is equal to 0, therefore this one will be equal to 0. Okay, so p01x for m is equal to 1, L is equal to 0, at that case the polynomial will be equal to 0. This is very important. We will come back to that later. And for m is equal to 1 and L is equal to 1, and in this case what will be the associated Legendre polynomial? The associated Legendre polynomial in this case, that is P11x, that is equal to 1 minus x square raised to m by 2, that is equal to 1 by 2, d by dx of p1x. P1x is equal to what is p1x? P1x is equal to x. P1x is equal to x, and therefore that is equal to 1 minus x square raised to 1 by 2. That is 1 minus x square is nothing but 1, that is 1 minus x square raised to 1 by 2. D by dx of x, that is equal to dx by dx, that is equal to 1 into 1. So that is 1 minus x square raised to 1 by 2. So I will write the rest of the things here. 1 minus x square raised to 1 by 2 is nothing but 1 minus cos square theta minus 1 minus cos square theta raised to half into 1, and that is equal to 1 minus cos square theta is equal to sin square theta, that is sin square, the root of sin square theta, that is equal to sin theta. Therefore P11x is sin theta. P11x, this one, is equal to sin theta. And now rest of the things we will put in another video, because this video is going to be already 30 minutes, so I will record the rest of the things in another video.